David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower to suit your desire. Second, you can pause the video at any point to jot down questions or catch up with your notes. Third, you can turn on the captions so you can read my words on the screen. Okay, we're going to spend a little bit more time solving for side lengths, and then we're going to do a little bit more complicated problem that you'll see in the coming exercises. But first, I just want to warm up. Let's do one more, find the length of a side. So this time, I really want you to pause the video and solve for x for this problem. Okay, let's see how you did. Set her up. You drew the diagram. Here's our theta, 63 degrees. Let's take a look. Hypotenuse right there. Here's my right angle, so hypotenuse is opposite. Now 63, looking out. 256 is the opposite side, and the one we want, x, is the adjacent side. So this problem deals with opposite and adjacent. That's tangent. Tangent's opposite over adjacent. So tan theta equals OPP over ADJ. So let's put in the information from this problem. Tan 63 equals 256 over x. Now we have the variable down low. You switch, you know. So the x comes up and the tan 63 goes down. So you have x equals 256 over tan 63. Pull out the calculator. Here, 256 divided by 63 tangent equals 130.44. So x equals 130.44. And yes, that makes sense. This definitely is shorter than this side. It's like not quite half, but getting kind of close to half of that, and kind of makes sense. Okay, let's do a little bit of a more complicated problem. Same ideas as we've been using in the other more simple ones, just all packed into one problem. So here's the instruction for this problem. Find all unknown angles and sides. So they're not giving you an x here, they're just saying, find out everything, right? So we know BC is 15. We don't know what AC is, and we don't know what AB is. So we're going to have to find 2 sides. Additionally, we have one unknown angle. We do know that that one is 90, so we don't need to find that. But we're going to have to find angle B. In fact, I'm going to start with angle B here. What do you need to know to figure out what that angle is? You've got to remember one key concept. In a right triangle, all 3 angles add up to 180. Okay? So, angle A plus angle B plus angle C equals 180. We know we can write that equation. Now we know a little bit of stuff here. We know that A is 90, so we can write 90 plus angle B we don't know, so we'll just leave that as angle B. Now angle C we know is 35 equals 180. So now all I have to do is subtract 90 and 35 from 180, and that'll give me angle B. So angle B equals 180 minus 90 minus 35. And you're probably rushing for your calculator. I'm going to do that one in my head. 180 minus 90 is just 90. 90 minus 35 is 55. Now there's a shortcut for that. In a right triangle, the 2 non-right angles always add up to 90. So that's a shortcut. So this plus something equals 90, and that gives you 55 with fewer steps. Okay, so I marked what we just learned, namely angle B is 55. So now I've marked that, so that's the first thing that we had to find. And let's just put that here kind of as a reference. Okay. So now we have to find the side length for AB and the side length for AC. Now we can use either one of these angles to do that. Okay, so I'm going to stick with the 35, And I'm going to use that to find side AC. So, using this angle, AC is adjacent. It touches angle C, and it's not the hypotenuse. So using 35, looking for AC, that's adjacent. Using the hypotenuse, that's the 15 that we know. So which function uses adjacent and hypotenuse? Let's write our SOHCAHTOA. S-O-H-C-A-H-T-O-A. SOHCAHTOA. So which one of those three uses adjacent and hypotenuse? That's cosine. So now I can write cos 35 equals, it's adjacent over hypotenuse, so that's going to be AC over 15. So I don't have to write x there, I can just write the letters that designate that side of that triangle. So now, my variable's up high, so you multiply the 15 times the cosine 35. So 15 times cos 35 equals AC. Pull out my handy-dandy calculator. Do 15 times 35 cosine equals, and I get AC equals 12.29. So that's this side here, 12.29. And that makes sense. It's pretty long, almost as long as hypotenuse, not quite, and 12.29, yeah, it's almost 15. So we're good there. Okay, so now let's find AB. What's that one? Let's make some room. So again, I'm going to use angle C. So AB is opposite of C. It's not adjacent, that was this side, and the hypotenuse stays the same, that's the hypotenuse. So to find AB, we're dealing with opposite and hypotenuse. Opposite and hypotenuse. Which trig function is that? That's sine. Opposite over hypotenuse. So now I can write sine 35 equals opposite, which is AB, over hypotenuse, which is 15. Okay? This looks a lot like that last equation. We had cosine 35 equals AC over 15. Do you think that's going to get us the same answer? Hold that thought. Let's do the math. Now we work our algebra on here. The variable's up high, so you multiply the bottom times the other sides. That's 15 times sine 35 equals AB. Pull out my handy-dandy calculator. Clear. 15 times 35 sine equals, I get 8.6. 8.6 equals AB. And let's take a look at our diagram. Does that make sense? If this is 8.6, yeah, that makes sense. This is quite a bit less than the hypotenuse. It's a little more than half. That kind of looks about right. Okay. Now, we found everything. We found the other angle, and we found the two sides. How could I check my sides? Think about that. I have a right triangle. Now I know all three sides. How could I check it? If you thought Pythagorean theorem, you're right. I can square this, add it to the square of this, and that should equal the square of 15, which is 225. So if you want to check that right now, pause the video, square 8.6 and add it to the square of 12.29, and that should be about 225. Some of you may have thought, well, if I know this angle, could I use that angle to find this side or that side? Because I used the 35 down here at angle C, but why not use the 55 up at angle B? And the truth is, you can. So let's do one of those and see and make sure that we get the same value for AC. Okay? All right, so starting with the process, actually if you want to pause the video, try that now. See if you can get that. All right, so if I'm standing in this angle and I want this side, what is AC to this angle? It's the opposite. And I know my hypotenuse, that's 15. So which function uses opposite and hypotenuse? That's sine opposite over hypotenuse. So now I'm going to write this equation. Sine 55 equals opposite, which is 12.29 over, oh no. We're going to pretend like we don't know that one right now. So we're just going to write AC over 15. Okay? So perfectly valid trig function, but instead of using 35, I'm using this angle and its opposite and hypotenuse. So let's work this math and make sure AC comes out to be 12.29. Variable's up high, so we multiply the bottom times the trig function. That's 15 times the sine of 55 equals AC. Pull out my calculator. 15 times 55 sine equals 12.29. AC equals 12.29. So I got the same result. I used a different equation. I used a different function. Remember, when we used 35, we used cosine to find this side. Now when I used 55, I use sine, but when we work the math, we get to the same place. Okay? So, to review, there's multiple ways to solve this problem. One thing you should not do in this chapter, don't use the Pythagorean theorem unless you're trying to check your work. But don't use the Pythagorean theorem initially. Use trigonometry. Otherwise, you won't be practicing what you need to practice. Now that you've watched the video, take a moment to jot down extra notes or jot down some questions for our next class. You can also re-watch portions of the video that you didn't get the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.